Good evening, and today I will be giving a step-by-step tutorial on how to perform calculations for this problem, which deals with stoichiometry and the Haber process. So our question is, how many grams of ammonia, which is this, will be made when 24 grams of hydrogen gas, which is this, react completely with nitrogen gas, which is this. We must follow a four-step process in order to avoid making any mistakes. The first step of our process is finding the rate-limiting reactant. Our rate-limiting reactant is hydrogen gas, or H2, because hydrogen gas has a bigger coefficient than the other reactant, which is nitrogen. Hydrogen has a coefficient of 3, nitrogen has a coefficient of 2. So because 3 is bigger than 2, hydrogen is our rate-limiting reactant. Our second step is to find moles of our rate-limiting reactant. So if we have 24 grams of hydrogen, and we know that each mole of hydrogen gas weighs 2 grams, then we have 12 moles of hydrogen gas. We know that a mole of hydrogen gas weighs 2 grams because hydrogen gas is a molecule that is made up of 2 hydrogen atoms. This is a covalent bond. These are 2 hydrogen atoms. They make up the hydrogen gas molecule. We know that a mole of hydrogen atoms weighs 1 gram because the average atomic mass of hydrogen is this, if we look at the periodic table, and this number can be rounded to 1 AMU. Therefore, 1 mole of hydrogen atoms weighs 1 gram. We have 2 hydrogen atoms here, so a mole of hydrogen gas molecules will weigh 2 times 1, which is 2 grams per mole. Our third step is to find the moles of ammonia formed. And in order to do this, we must use a proportion where our rate-limiting reactant, or hydrogen, is in the numerator of the proportion, and our product of interest, which is ammonia, is in the denominator of the proportion. So if we look at this very carefully, we should see that 3 divided by 2 is equal to 12 divided by x. If we cross multiply, we will find that 3x is equal to 12 times 2. 3x is equal to 24. If we solve for x, which is the moles of ammonia formed, we find 8 moles of ammonia formed. And this is our answer to step 3. Our answer makes sense because if 3 moles of hydrogen make 2 moles of ammonia, then 4 times as many moles of hydrogen should make 4 times as many moles of ammonia. And this is true because 8 is 4 times bigger than 2. Finally, when we have the last step, which is converting moles of ammonia formed to grams of ammonia formed, we simply multiply the moles of ammonia formed by the molar mass, which is 17 grams per mole. We know that the molar mass of the ammonia molecule, which looks like this, is 17 grams per mole because ammonia has 1 nitrogen atom, and a mole of nitrogen atoms weighs 14 grams, and it has 3 hydrogen atoms, and each mole of hydrogen weighs about 1 gram. So 14 times 1 plus 3 times 1 is equal to 17 grams per mole. We multiply 17 grams per mole, which is the molar mass of ammonia, by the amount of ammonia in moles, and we find 136 grams per mole, which is our final answer. Therefore, using this four-step process, we know that 24 grams of hydrogen gas will make 136 grams of ammonia if the hydrogen gas reacts completely with the available nitrogen gas.